All right, for this one, Marissa, let's read.
The base of a solid is the region in the first quadrant bounded by the y-axis, the x-axis, the graph of y equals e to the x power, and the vertical line x equals 1. For this solid, each cross-section perpendicular to the x-axis is a square. What is the volume of the solid?
So we're looking at, here's my x and y, and we have e to the x, that looks something like this, and then x equals 1. And I'm going to shade in the spot that we're going to find the area. So we're looking at that rectangle. So if I were to find the integral of that, if I were to scan this rectangular figure left and right, it's going to go from 0 to what?
1.
0 to 1. And then top one is e to the x minus, on the left or the bottom is 0, dx. And there's something that we're missing. We have a square. Square is all what?
Square.
Squared. And this part is non-calc. So let's do this one by hand. So we have integral. And let's simplify this guy right here, 0 to 1. When I distribute my 2, I get e to the 2x. And 0 really doesn't matter, right? So let's do our u substitution. If u is equal to 2x, then du is equal to what? 2 dx. And I'm looking for just dx. So let's kick off the 2 over. And now we can go ahead and substitute in. So we have, let's kick out the half. And then we have e to the u du. And I want to go ahead and convert our bounds. If x equals 1, then u is equal to what? Plug it in right here. 2. If x equals 0, then u is equal to 0. So we have 0 to 2. So then if I integrate from here, we get half e to the u. And then we're going to actually find it from the bounds between 0 to 2. Why am I not putting plus e? Because we have the bounds. Okay? So when I plug it in, I'm going to start by plugging this one into my u. You get half of e to the 2 minus, and then plug in the bottom bound, 1 over 2, e to the 0. And what is e to the 0? So we don't really need this. That will be our final answer, which caused us to get which letter? B. Very good.